In this video, we are going to learn sampling distribution for proportions. Sample proportions is a numerical summary of the binary outcomes. When we say it is binary outcomes, it means we only have two outcomes. It is 0 or 1. Since the sample proportion will vary for each sample taken, it can be thought as a random variable. The notation is called p hat. P hat will be used to represent the sample proportion. This value will either be given to you as the proportion based on a sample, or it can be calculated as the p hat equals the x divided by n. X is the number from the sample with the character. The n is the sample size, or the total number of the people sampled. Note that the p hat will be different for each sample taken from the population. Here are some properties of a sampling distribution of a sample proportion. The mean for the sampling distribution for the sample proportion will depend on the population proportion. The population proportion is denoted as P. The sample proportion is denoted as mu p. So if you were to pull out all possible samples of a given sample size and calculate the sample proportions, then the average of all these possible sample proportions will come out to the population proportion, which is p. The standard deviation for the sampling distribution of the sample proportion depends on the sample size n and the population proportion p. The standard deviation of all possible sample proportions gives us the standard error of a sample. The standard error of a sample, sigma p, is calculated as the square root of p times 1 minus p and divided by the sample size n. The shape of a sampling distribution is known for large n to be approximately normal. This can actually be shown by central limit theory. If n is sufficiently large so that the expected number of outcomes of the two types, np in the category of interest and n times 1 minus p, which is not in the category of interest, are both at least 15, then the sampling distribution of a sample proportion is approximately normal. If np is larger or equal to 15 and n times 1 minus p larger than or equal to 15, then we can say the sampling distribution of a sample proportion is approximately normal. Therefore, it has a bell shape. If any of these two conditions are not met, then the data is not approximately normal. There are benefits of knowing the sampling distribution is normally distributed. First, we can determine the number of standard deviations away from the mean, or the true proportion of the population, given a sample proportion, is by using z-score calculation with some changes in notation for proportions. So now the z-score will be calculated as the p hat minus p divided by the sigma p. So remember that the sigma p should be calculated as the square root of p times 1 minus p divided by n. If the z-score is greater than 3 standard deviations above the mean, or 3 standard deviations below the mean, then the sample proportion is considered as unusual. So 3 standard deviations above the mean means we have a positive z-score larger than 3, or less than 3 standard deviation below the mean means we have a negative z-score less than negative 3. Here is a summary of a sampling distribution of a sample proportion. Sampling distribution of sample proportions looks at all possible values you can get for the sample proportion for a given sample size. And it is centered at the mu p equals p. The p is the population proportion. The average distance values the sample proportion from the population proportion is standard error sigma p. It is called the standard error, and the more sample we put as n increases, the smaller the variability will become. The sampling distribution of sample proportion is normally distributed if np is larger or equal to 15 and n times y minus p is larger or equal to 15. Both conditions must be met at the same time. We can find the likelihood or the probability of getting a particular sample proportion by using the following z-score formula and the normal table. This is an example from your textbook. You can pause the video and read the question. First question. Define a binary random variable and give the probability distribution. So the binary random variable is the acceptance of the invitation or the non-acceptance of the invitation. We define x equals 1 as the acceptance of invitation and x equals 0 as the non-acceptance of invitation. According to the context of the questions, it is known that there is a 10% chance that any particular customer will accept the offer. So when x equals 1, the probability of x equals 1 will be 0.1, and the probability of the x equals to 0 will be 0.9. First question. Find the mean and the standard deviation of the sampling distribution of the sample proportion of the 500 potential customers sampled that will accept the invitation. So we know that the mean of sampling distribution of sample proportion should equal to the mean of the population distribution. So that's why the mean p should equals to 0.1, and the standard deviation should be calculated using this formula. If we want to calculate the standard deviation of a sample size of 2000, then you can notice that the standard deviation of a sample size 2000 will decrease compared with the standard deviation from the sample with sample size 500. As you can see, this number is smaller than this number. However, if we decrease the sample size to 125, we can see an increase of the standard deviation of the sampling distribution. We can find the probability of any interval of sample proportions by finding the area under this normal curve. You need to follow these 4 steps. First, sketch your curve and shade the area you are looking for. Pay attention that this new curve will be centered at the mu p equals p. The p is the population mean. Mu p is the mean of the sampling distribution. Second, you need to use the new formula to convert a value of p hat to a z-score. So this is what we call the new formula. Then you want to use the normal table to find the area to the left. The last step will be find the shaded area. Pay attention that this x-axis no longer represents the different values x can take. Now the x-axis represents the different values p hat can take. Here is another example from your textbook. You can pause this video and read the question. From the context of the question, we know that the mean of the sampling distribution equals to the population mean. We can define the random variable x as when x equals 1, it represents it getting a hit, and when x equals 0, it means not getting a hit, and the sample size is 500. and the standard deviation will be of the standard deviation of the sampling distribution will be calculated in this way. Then we want to determine the shape of the sampling distribution. Size n times p, n which is n is 500 equals 150, and n times y minus p is 350. Both this number and this number are large or equal to 15. So the sampling distribution is approximately normal distributed. So it has a bell shape. Explain why a betting average of 0.320 of 0.280 will not be especially unusual for this player's year-end betting average. Since we just said the sampling distribution has approximately normal distribution, we can calculate the z-score and determine if a given value for the sample proportion is considered unusual. When it's unusual, it means the z-score is smaller than -3 or larger than +3. So first, let's denote the p-hat as 0.320. So we can calculate the z-score in this way, and the z-score is positive 0.98, which is smaller than +3. Next, we can let the p-hat equals 0.80. Then the z-score will be calculated in this way, which is -0.98. Negative 0.98 is larger than -3. So that's why both those values are not considered as unusual. So this one is smaller than +3. This one is larger than -3. And both are considered as usual. Or in other words, since both are within one standard deviation of the mean, these values are not unusual. Question C. Find the probability of a betting average greater than 0.33. Since we just said that the sampling distribution has approximately normal distribution, we can draw a normal curve and find the area under the curve to get the probability. And we want to find the probability that the p-hat is larger than 0.33. It means we are looking for the area to the right. So we need to calculate the z-score using this formula here. And we can use the normal table to find the area of this transparent area. From normal table, we know that the area of the transparent area is 0.9279. So we can use 1 minus this number to get the shaded area. It means the probability that the p-hat is larger than 0.33 equals 0.0721.